Okay, welcome back everyone. Today we're going to learn about minerals and the definition of minerals. To do that, we are going to make a foldable. And as you see on our screen up here, I have an example of a foldable. And to start, what we would do, and you can work along with me please, is take the piece of paper and fold it just like I'm doing right now. You guys go ahead and do the same thing. Okay, just fold it all the way down to the bottom. Okay, and we're going to be talking about these different things here that go along with the definition of a mineral. And we've been talking a little bit about this stuff. So just to review, naturally occurring, inorganic, solid, with a chemical structure and a definite chemical composition. So what we're going to do is we're going to open these up. And we're going to create this foldable so that we can examine and explore a little bit more about each of these details. So if you can work along with me, you're going to open it up and you're going to cut little tabs. So halfway in between each space, you're just going to snip about to the point where we get to the folded crease on your paper. And then go down and do the same thing for the inorganic section. You can cut that part. Go down and snip a little tab for solid, and then crystal structure, and you should have something that looks like this when you're done. You see, you're going to open it up, and we can write on the inside here for each of the characteristics of a mineral. Okay, and as we go, we're going to take some notes and jot down some ideas that go along with each part. Now, from our homework assignment last week, we actually struggled with understanding some of the parts of a mineral. And we kind of misidentified some of the things in our house that we thought were actually minerals. And in fact, they were not minerals. So what we can do is we can actually basically test these different items to see if they are minerals by looking at the definition naturally occurring. So what I'd like to do is I'd like to start out by just taking the naturally occurring section, that little tab, and opening it up right here. Okay. Next I'll zero in a little bit for you. I'll enlarge it. There we go. So you can probably see it a little bit easier. Okay. But there is something about this naturally occurring tab that I want you to know. Okay. What I want you to know is that it's formed. It's formed by natural processes. Formed by, let's just put formed by processes, and that means a way of doing something. If you have a process, it's a way of doing something. But we're going to put down in the natural world. In the natural world. In the natural world. Now, things like humans that make things in a laboratory would not count here. Okay, so like plastic, for example, that's actually made of oil. Plastic actually is made in a laboratory or in a factory by humans. That is not a mineral. Okay, so if it's made, remember the word synthetic? The word synthetic means man-made. Synthetic things are not minerals, so let's be clear about that. And this part right here would go along with it. It must be naturally occurring. That comes from the world or the earth, okay? So next I'd like you to open up the next tab, which is inorganic. You see the root word organic? That word, remember, comes from living things. So inorganic is the opposite. So flip that part open, and let's write down a few pieces of information here that would help us along with that, okay? Write down never formed. You see, if it's a mineral, it would never be formed, from materials that were once living. So everybody right now start thinking about materials that would be found in the environment that would come from once living things. Can you think of something out there that you may find in the environment that would be a little confusing, that some people might actually think would be a mineral that's not? Like, think about it. Like hair, for example. That came from a living thing. So like dog fur, for example. That would be classified as organic. It came from a living thing. So that would not be a mineral. That is not from a living thing. Or an inorganic means that it comes from not from a living thing. So the opposite would be like bone. Bone comes from a living thing. That is not a mineral. Okay, so if you have bone fragments in something, or maybe like I said, hair or scales, or like things like shellfish, you know how they have the shells on it? That would be all living things, right? So that would not be a mineral. All right, so if it passes that test. So first you start thinking, did it come naturally? Huh? Is it inorganic? Huh? Well, there's something else too. It must be solid. Okay, so open up your solid tab. And remember last chapter, we learned about the solid liquids and gases, and we were talking about the definition of a solid. Remember, it means to come from it has definite volume. Everybody write that down, definite volume, which means that it takes up space and shape. So a mineral would not be a liquid. A mineral would not be a gas. Now some people might be a little puzzled or confused because, you have mineral water, right? Well, yes, there's solids actually possibly on a molecule level that could be in the water or the liquid. But in order for it to be a mineral, it's not in a liquid form. Okay, it'd have to be in a solid form. All right, close that one. Open up crystal structure. Crystal structure. And last Friday, we actually had an example during class where we evaporated some salt water. And we have little petri dishes over in the corner of the classroom. And later on, we will take the actual sample and we will look at them closer under the microscope. And hopefully we can actually show and point to crystal structures that were formed there. Well, to elaborate or to explain more, that means that we are going to be looking for patterns. So write that down. Patterns that repeat over and over again. So minerals must have patterns that repeat. That's kind of an important thing for it to be a mineral. Patterns that repeat. Crystals are really cool. In fact, later on we're going to be studying different types of crystalline structures. We have this project called Crystal Cave Project, and we have a chance to actually draw pictures and diagrams of different types of crystals. Okay, everybody close that one now. Crystal structure. And open up, it says definite chemical composition. Now, people might be looking at me like, what? What does that mean? Well, this one ties neatly with our last chapter that we were working on. If you remember when we were talking about atoms and we were talking about, well, how they are put together, how are the elements put together? They form compounds, right? Sometimes the molecules form compounds. Well, a mineral must have a definite chemical composition. Okay, now let's open this up. And that actually means that it contains, so write this down, it contains certain elements. In definite proportion. There's a math word for you, proportion. That means that it must have the same amount every time. The chemical structure that forms the mineral must have the same stuff in it over and over again. Okay? It must have like a compound. I'm going to write in parentheses compound. Well, it could be a molecule or a compound, but a compound has a set structure. It has a set chemical composition. Like, for example, I'm going to use the example of water, for example. Water I know water's not a mineral, but it has a chemical composition of H2O. It has 2 hydrogen atoms and an oxygen atom. So a mineral must have a definite proportion, just similar to like maybe water. Okay? So in order for your item in your house, or your item, whatever it is, your substance to be classified as a mineral, it must be naturally occurring. It must also pass the test of being inorganic. It also must be a solid, so it's not a liquid or it's not a gas. It must be a crystal structure, and it must have a definite chemical composition. Okay? Now, these items here I do want you to study for Thursday. You'll be quizzed on this item, all of these things here. And I may even have some substances that you may have to go through and tell me if you think that it's a mineral or if it's not a mineral. Okay, so you'll need to apply that information as well. All right. Now at this time I'm going to